A plastic sleeve of outer radius R0 is equal to 1 mm covers a wire radius R 0.5 mm carrying electric current. Thermal conductivity of the plastic is 0.15. The heat transfer coefficient of the outer surface of the sleeve exposed to air is 25 watt per meter square Kelvin. Due to the addition of the plastic cover, the heat transfer from the wire to the ambient what will happen to the heat transfer, whether it will increase, decrease, or it will remain constant. So you must be knowing about this fact that whenever you add the insulation, what happens is till a certain, the insulation is provided to prevent the heat transfer. But what happens sometimes that if you, there is a one critical radius where the heat transfer is maximum because the convective heat transfer takes place then. Now, here we have to determine the critical radius of the insulation, and it is given by K by H, and K is given as the K is nothing but thermal conductivity. It is 0.15, and convective heat transfer coefficient, it is 25. Okay, simply 6 mm. So as you can see that the critical radius of the insulation is 6 mm, but the outer radius of the plastic sleeve is just 1 mm. So you must be aware of this thing that when you draw a graph like this for critical radius of insulation, it goes something like this, and this is the radius or the critical radius of the insulation, and it is coming out to be 6 mm, and this is the heat transfer. Over here it is maximum, this is Q max. Alright. Now as you can see that the outer radius is R0 is equal to 1 mm. So when you will increase the thickness, what will happen? Since 1 mm or the present outer radius is smaller than 6 mm, so what will happen? The Q will keep on increasing till RC. But as soon as it will cross the limit of RC, it will cross the limit of 6 mm, the Q transfer or the heat transfer will drop down. It will sink. Alright. So the correct option should be it will increase. It will increase. Till RC it will increase, but after RC it will drop down.